Mrs. Sanders has 3 grandchildren who call her regularly. One calls her every 3 days. One calls her every 4 days. One calls her every 5 days. All three called on December 31st, 2016. On how many days during the next year did she not receive a phone call from any of her grandchildren? Let's say if the day is a multiples of 3, one of them calls. If the day is a multiples of 5, another grandchildren is calls. If a day is multiples of 4, and the other one is calling. They must be not a multiples of 4, not a multiples of 3, not a multiples of 5, so that all 3 grandchildren do not call her. And let's write in the modular arithmetic. The day is n is congruent to some r1, not a multiples. It should not be a multiples of 3, mod 3. So r1 values is either 1 or 2, not 0. So the first grandchildren is not calling. And is congruent to r2 in mod 4. The second grandchildren is not calling, then the values for R2 is 1 or 2 or 3, can't be 0. And n is the day congruent to R3, some remainder in mod 5. Not a multiples of 5. R3 is either 1 or 2 or 3 or 4, not 0. Chinese remainder theorem says that since these modes are relatively prime number, they don't share a common prime factor, we have a unique solution for n in mode product of the modes, which is 3 times 4 times 5 equals 60. In mode 60, we have a unique solution. Chinese remainder theorem guarantees that. Let's say that solution is, let's say, some A. And how many different system of congruences we can make and create here? For R1, we have 2 options. For R2, we have 3 options. And for R3, we have 4 options. Then from multiplication principle, 2 times 3 times 4, which equals 24, I can create 24 different system of equations. And for each system of equations, I have a unique solution when in mode 60, less than 60, I have a unique solution. It's not equal to 60. So from 0 to 60, actually 1 to 60, I have 24 solutions for that, 1 to 60. Also from 61 to 120, we have another 24 solutions. And if we think 365 days, it's not a leap year, 365 days, we have 6 groups of 60 inside. So for each of them, from 121 to 180, we have another 24 solutions. So 24 times by 6, since 360 divided by 6 equals 60 is equal to 6. We can have 24 times 6, that many names, which is 6 times 4 is 24, 6 times 2 is 12, plus 2 is 144 days. But we should also consider after 360. 361. This one is not a multiples of 3, not a multiples of 4, not a multiples of 5, so nobody calls. 362 is not a multiples of 3, not a multiples of 4, not a multiples of 5. That's also we have to include. 363, that's a multiples of 3. One of them is calling. And 364, multiples of 4, one of them is calling. 365, multiples of 5, one of them is calling. So we have to include 144 days, 2 more days. Just 361st day and 362nd day. So the answer is 146, which is option D.